Welcome to the Explainer. Today, we're going to talk about a design pattern that can seriously clean up some of the most tangled, messy code you've probably ever had to deal with. You know, if you've ever found yourself just lost in a jungle of conditional logic, then this one is definitely for you.
All right, let's just dive right in by starting with a problem that I'm pretty sure every developer recognizes, that dreaded, ever-growing block of if-else statements. It always starts out so simple, but it just never ever stays that way. So just imagine for a second, you're building, say, an online ordering system. Every single request that comes in has to pass a bunch of checks before it can actually be processed. You start with a simple if for authentication, but pretty soon you're adding more checks for data validation, maybe for brute force attacks, caching, you name it.
And before you know it, your code becomes this giant, bloated mess. With every new feature, it just gets more and more fragile. Changing one little check might totally break another, and trying to reuse any of this logic somewhere else in the system? Yeah, good luck with that. It's just a nightmare to maintain.
So, the big question is, how do we fix this tangled mess without having to rewrite the whole thing from scratch? How do we bring a little bit of order to all this chaos? Well, the answer lies in forging a chain. The solution is this really elegant pattern called the chain of responsibility. What it does is it transforms each of those individual checks into its own standalone object, which we call a handler. So instead of having one massive method, you create a whole series of linked specialists, and each one has just a single job to do. And this is the really crucial idea here. The pattern completely decouples the object that sends the request from all the objects that actually process it. The sender has no idea who's going to handle the request, or even how many handlers are in the chain. It just sends it off.
Okay, to make this feel a bit more real, let's look at a couple of real-world analogies that I think perfectly capture how this whole thing works. Think about the last time you had to call tech support. Your request gets passed up the chain, right? First, you probably get an autoresponder for the really common stuff. If that can't help, you get passed to a live operator. And if they're stumped, your call gets escalated up to an engineer. Your request just keeps traveling along that chain until someone can finally solve it. You actually see a very similar thing at work in an ATM. When you ask for cash, that request is first sent to the dispenser for the largest bills. It spits out as many as it can, and then it passes the remaining amounts, the rest of the request, down to the next dispenser for the next largest bill, and so on, all the way down the chain. All right, let's get into the nitty-gritty and look at the blueprint for this pattern. Now, you might be expecting something really complex, but the underlying structure is actually, well, it's beautifully simple, and that's what makes it so powerful. At its core, when you boil it all down, the pattern just consists of a common handler interface that all of our concrete handlers implement. And here's the key part. Each handler holds a reference, a link to the next handler in the chain, its successor. So that leaves us with three main players on the stage. You've got the handler interface, which sets the rules. Then you have the concrete handlers, things like an authentication handler or validation handler. They're the ones doing the real work. And the client? Well, the client only needs to know about the very first handler in the chain. It just fires off its request, not knowing or even caring who ultimately takes care of it. Now, I know what you might be thinking. This sounds like a lot of extra work, right? Why set up this whole chain of objects instead of just, looping through a simple list? Well, as it turns out, the advantages are pretty significant. The benefits are huge. You get that loose coupling we were talking about, which is great. And you get this incredible flexibility to reorder operations, even while the program is running. But it does come with one major catch, which you can see here. Because there's no guaranteed receiver, a request could, in theory, travel the entire chain and never actually get handled. And this is where it gets really cool, because the pattern just brilliantly illustrates how you can adhere to these core principles of good software design. Each handler has a single responsibility, just one job, and your whole system is open for extension. You can add a new check just by creating a new handler, but it's closed for modification because you don't have to touch any of the existing code. It's awesome. This distinction really helps us see why the chain is so much more powerful than a simple list. See, with a list, you've got some outside loop that calls each handler one by one. But in a chain, the handlers call each other. And this allows for much more complex interactions, like a handler doing some work, passing the request on, and then doing more work after the rest of the chain is already finished. So ultimately, the big takeaway here is this. The chain of responsibility pattern gives you a really clean, flexible, and scalable way to process requests. So the next time you find yourself writing one of those super long series of if-else statements, just stop and ask yourself this question. You might just have found the perfect candidate for a chain.